Natural disasters are extreme and sudden events caused by environmental factors, resulting in the loss of human lives and extensive property damage. In recent years, it has been observed that the chances of disasters occurring are increasing due to climate change. Despite the available wireless networking and data transmission capabilities in today's era, situational awareness among central disaster management entities is limited to implementing predetermined actions, applying restrictive measures, and developing networks for voice commands only. The use of these tactics not only hinders the easy dissemination of information among superiors and subordinates within an operation but also complicates effective management and control, especially when aerial assets are involved, which require much shorter reaction times based on their capabilities. The Avicom project is being executed in collaboration with 4 entities. Specifically, the University of Thessaly, UTH, Intricom Defense, IDE, the Ministry of National Defense, MOND, and Inspire Web are part of this consortium. This research project aims to develop an innovative solution that focuses on the implementation of a network-centric method for information dissemination. These pieces of information will contribute to improving situational awareness. They will also enable optimal management and control at a tactical level for personnel and resources of civil protection agencies involved in disaster response. The main characteristics of this application include its open architecture, relatively low implementation cost, simplicity, usability by both ground and aerial assets, and resistance to interference, spoofing. To achieve the above, the development of a wireless network prototype for bidirectional routing of encrypted real-time data is carried out. These data will include position information, GPS, tactical level geographic information, command instructions, and more. In addition to the network architecture, a suitable graphical communication environment is being developed for the visualization of this information, both for portable devices and fixed workstations. These applications have the capability of integrating, creating, and displaying all geo-informational data exchanged within the network. The proposed system can be implemented in both ground and aerial assets operating under various conditions. Next, there is a description for the contribution of the University of Thessaly as the coordinator in the Avicom research project. The primary goal was the thorough analysis of requirements for the creation of a system that could be applied to a variety of operational scenarios. Through the coordination carried out by the team at the University of Thessaly, both the specifications and metrics of the proposed system were derived. Subsequently, the system architecture was designed by the University of Thessaly team in collaboration with other project partners. In this specific architecture, a novel long-range wireless communication system is proposed to be installed in the involved assets of an operation. The project involves the development of novel gateway devices, GWs, for the establishment of the proposed network. Specifically, the gateways consist of both the intermediate medium device, IMD, developed by the University of Thessaly and the standard wireless devices developed by Intricom Defense in the project. Here is one of the 3 similar intermediate medium devices developed by the University of Thessaly for this project. During the final testing phase, one of these devices was installed at the ground station, while the others were installed on 2 Huey helicopters. This device features network interfaces for its connection both to the operator's mobile device and to the novel device of Intricom Defense. The intermediate medium devices have multiple functionalities. Initially, a suitable communication protocol, API, was developed for these specific devices, allowing for the decoding and storage of data collected or generated by mobile devices, Android, and the ground station. The storage of this data is done in appropriate databases for further processing and dissemination within the network of involved assets. Additionally, a suitable network communication protocol was developed by the University of Thessaly team for the intermediate medium devices, aiming at the dynamic management of information exchanged within the network. Specifically, this protocol implements mechanisms for sending information via an alternative wireless 3G, 4G network when there is no connectivity between the standard wireless devices developed by Intricom Defense in the project. Multiple actions have been taken during the Avicom research project to verify the desired functionality of the proposed system. Initially, a thorough examination of the operation of various wireless standards was conducted through the simulation of different operational scenarios in a laboratory environment using real wireless devices. This action was completed in collaboration between the University of Thessaly team and Intracom Defense. Additionally, part of these scenarios were executed by the University of Thessaly team using unmanned aerial vehicles, drones. Finally, the overall operation of the proposed system was successfully tested using helicopters from the 1st Army Aviation Brigade. The main role of Intracom Defense in the project was the implementation of a secure and resilient flying ad hoc network for connecting aerial resources with the command and control center, as well as the development of the management and control software for the ground station. Intracom Defense also played a key role in defining the system requirements, implementing sufficient security mechanisms to ensure the operational integrity of the system, as well as integrating the systems, installing, and demonstrating the final solution with the Army Aviation aerial platforms. We will start by presenting the pilot construction consisting of hardware and software, specifically with the technical characteristics of the wireless communication device that is a significant and integral part of the novel gateway device, which is developed in this project. This standard device is based on the combined operation of the intermediate device of the University of Thessaly and the wireless device of Intracom Defense, which are interconnected through an Ethernet interface. During the initial project tasks, Intracom Defense identified that the solution that would meet the project's needs would be the integration of the selected wireless technology into one of its graded infrastructure platforms. These platforms are designed in such a way as to provide a very good application for multi-purpose networking, interconnection, and multiplexing of data and voice services to and from local or remote networks. The final devices designed by Intracom Defense are typically ready for installation on aerial and ground platforms, carriers for civil protection applications, while they can also meet the requirements and specifications of defense systems. For this purpose, the TMN2400 platform of Intracom Defense was selected, and the overall solution implemented incorporates mobile ad hoc networking wireless technology. Intracom Defense allocated resources in terms of hardware for the design and production of 3 industrial prototypes for the project's needs, namely for integration in the laboratory as well as for the final tests with the aerial means. Here is one of the 3 similar Intracom Defense wireless devices developed for this project. During the final testing phase, one of them was installed at the ground station, while the other 2 were installed on 2 Huey helicopters of the Army Aviation. The TMN2400 product with the corresponding configuration can potentially function as an IP routing gateway, wireless LAN gateway, radio gateway, BMS communication hub, and additionally supports the CCU units of Intracom Defense. Furthermore, it supports tactical terminals with advanced processing capabilities and GUI, HMI. Here, the TWM card is shown, which was developed, integrated, and customized in hardware and software to be used in the project. The TWM card is a broadband data and voice services transceiver designed to be installed in the TMN2400 unit as an expansion card to provide wireless MANET data connectivity in the UHF band. The card includes a GPS module and onboard non-volatile memory for secure storage of encryption keys to encrypt data, which is implemented using a high-security embedded algorithm. Intracom Defense designed and developed a management and control software for the ground station based on the existing iDefender software suite. iDefender is based on an open architecture, making it easily expandable and manageable to meet the needs of each project. For the Avicom project, Intracom Defense designed a plugin that supports the following functionalities. Firstly, it receives helicopter positions and displays them in real time on a geographical map, simultaneously showing critical information such as geographic location, altitude, speed, heading, and the status of the connection with the ground station. Secondly, it can send and receive short text messages to helicopter groups or individual helicopters, assisting in communication between the groups during demonstrations. Thirdly, it supports the design of geometric shapes on the map and their distribution to other users. Regarding the map design, high-precision altitude maps of Greece have been integrated into the application's geographical background, which contribute to the design of routes for helicopters. Additionally, the display of various symbols and geometries on the map is in accordance with the guidelines of the 1st Army Aviation Brigade. The iDefender application was seamlessly adapted to the project's needs, achieving full interoperability with the Android mobile application installed on the operator's tablets in the helicopters. Below, a short description is given for the preparation and the execution of the final experiments, which were carried out in this research project. At the same time, a demonstration of the mobile Android application developed by Inspire Web will be also provided. The preparation of the aerial tests for the system began on November 26, 2021, with the visit of personnel from the University of Thessaly and Intracom Defense to the facilities of the 1st Army Aviation Brigade in Stefanovicchio, Magnesia. The purpose of the visit was to conduct an inspection to gather information related to the installation of radio systems and electronic devices of the Avicom system, both on the Huey helicopters and at the ground station installation site. After studying the technical characteristics of the Huey helicopters and their communication capabilities, it was deemed more suitable, for the communication of the Manet network prototype developed in Avicom project, to utilize the UHF-AM antenna of the aircraft and the existing cable routes without any structural modification. In addition, regarding the mobile Android application of the Avicom project, after submitting the program specifications, the operators team of the 1st Army Aviation Brigade involved in the program remained in constant communication with the personnel of Inspire Web who were responsible for implementing the Android mobile application. Through this communication, the development of the mobile application was completed in mid-June 2022. This version was delivered to operators from 3 different military units for testing during flights and to identify any errors, faults, failures, or defects in the application. No deviations were detected during the trial use, and some observations from the operators regarding the user experience were relayed to the Inspire Web team. After performing the corresponding software upgrade, the application was delivered in November 2022 for the final phase of testing. The final phase of the experiments took place at the headquarters of the 1st Army Aviation Brigade from November 14 to 18 of 2022, involved the full activation of the proposed system. Specifically, in 2 helicopters designated for the trials, an installation was carried out both for the Manet Intracom Defense device, as well as for the intermediate device from the University of Thessaly, which collects and manages the information between the mobile Android device used by the operators. After the installation of the developed devices in the helicopters and the network verification through ground testing, the aerial trials began. These took place in the wider area of Stefanovicchio Airport, where the rich terrain allowed the examination of various scenarios related to network connectivity. The scenarios varied in terms of transmitted power, distance, and the presence or absence of line of sight between the helicopters and between them and the ground station. The system performed according to its operational specifications in all examined scenarios. Specifically, the smooth operation of the system was observed despite the interruption of line of sight between the devices due to interference from buildings or minor terrain irregularities. Additionally, even when the transmission power of the wireless device from Intracom Defense was reduced to 0.5 watts, the ground station continued to communicate with the helicopters, even though they were positioned more than 10 kilometers away and flying at an altitude of 200 feet. The communication between the ground station and the helicopters was only interrupted when significant terrain irregularities obstructed their line of sight. However, even in this case, the system continued to perform according to its specifications as it automatically switched to the backup communication configuration, utilizing the 3G, 4G mobile network through the intermediate device provided by the University of Thessaly, allowing the ongoing exchange of messages. Finally, it is worth noting that the contribution of the Ministry of National Defense was significant both in the analysis of the system specifications and in the execution of the final experiments.